Hey everyone, welcome back to another video here on DarkSec. I am Dark, and today we're going to be taking a look at the room History of Malware on TryHackMe. So you'll join this room to learn about the first forms of malware and how they turned into the malicious code that we see today. That being said, let's go ahead and jump right into Task 1, Introduction. This room is dedicated to the first types of malware. Malware consists of two words combined, malicious and software. Typically, malware is designed to cause damage to computers or networks. This may be on a very large scale or only on a local network, so a LAN in that case. This will teach you a small backstory on how malicious software, malware, has evolved into the complicated viruses you may be exposed to today. And then the room creator has also put their Discord name down here, very kind of them. This was designed by Jabba, who is one of the, I believe, subreddit staff. And he's a community mentor in the Discord, and he did a great job on this room. That being said, we'll go ahead and mark this as completed, and we'll dive into task number 2, the Creeper program. So, very old screenshot up here. This is definitely from a DOS-era computer, and we'll see a little bit more of that today, but this is one of the earliest forms of malware. Concepts of malicious software have been around since 1949. That's old. And one of the first known theories was created by John von Neumann. Von Neumann, who also devised the von Neumann architecture, which is very simply how computers actually transfer data to their hardware. Very interesting. You should definitely look into that, especially if you want to learn more about how computers actually do all the magic underneath the scenes. He produced work detailing self-replicating computer programs. This design is arguably the world's first computer virus, but in reality, it is the first concept or design for a computer virus. This concept was proven 22 years later. This is the basic diagram of the von Neumann architecture. So we can see how we have the input device feeding into the actual central processing unit here. And you can look a little bit more into this if you are interested. This is definitely something that I do recommend taking a look at. It's very, very cool. The Wikipedia page on this can get a little overwhelming quickly, so read it a couple times and it'll make more sense. So the Creeper program. The Creeper program, also known as the Creeper worm or virus, was the first ever virus to be created. Written by Bob Thomas in 1971, the program used ARPANET, which is the Advanced Research Projects Agency Network, which was the internet in its very early stages, to transfer itself between computers. Keep reading to learn about ARPANET. And again, something definitely you want to look into. Creeper was created in the programming language PDP-10 assembly, which ran on the operating system Tenix. Bob Thomas came up with the idea from the unreliability of computers. Computers fail from time to time and work is lost. So I got interested in the possibility of moving an executing program from one computer to another without interrupting the ongoing operation of a program, at least to the extent that to an external observer nothing has happened. And this is actually part of where we get the concept of, if you are doing any cloud computing, high availability. Very, very cool. Especially if you've done any AWS, you can see how a lot of these concepts start coming into play with malware creation. And this led to the design of the program. You might be thinking, what did Creeper actually do? Well, I'll tell you. Creeper would iteratively display the following message onto the connected teletype computer screens. I'm the Creeper, catch me if you can. That is all the program would do, which is why it's not technically malware. It did not cause any harm to the computers or networks it visited. That is slightly off because malware also is often defined as something that you did not intend to run. It's something that the owner of the computer did not approve running. But it's worthwhile to include because, again, you can see how this is a direct precursor with the self-replication bit. Robert, the creator, purposefully coded it so that it would remove older copies of itself before transferring to the next computer. This was proven useful as some of the software we will talk about in this room does not do that, and it can cause additional accidental harm by copying to the computer multiple times. Ray Tomlinson, and I probably just butchered his name, later redesigned the Creeper virus to copy to each computer, rather than deleting the older copy of itself. Some people claimed that this caused damage because, as said above, the program would accidentally copy to the same computer multiple times, but this was never proven. But what I did find was an interview with Ray Tomlinson. he stated that only 23 computers were infected, and all of the operators of those computers gave permission, and even we only ran it a few times, mostly on our own machines for debugging, so it never became a nuisance. And you can read that full interview here if you want to know a little bit more about that. And then, if you grew up on Scooby-Doo, I know I certainly did. This is a fun reference. Creeper was surprisingly named after the green ghoul on Scooby-Doo, which is one of the iconic villains from the classic Scooby-Doo cartoon. So ARPANET. ARPANET originally started out with two networking protocols, remote login and transferring files. After their project was denied, the team working on this project, known as the Network Working Group, decided to design a program formerly called the Network Control Program. Without all the unnecessary details, this is the start of computers being able to communicate within networks, and where we start seeing the birth again of that modern internet forming. So packet switching is breaking data into packets to send to to then route or send said data to the receiver. The receiver, which is the computer that's receiving the data, will then reassemble the packets back into whatever data/file was sent, and that's still being used today. That's still how we transfer files at a very high-level overview. This was the main way that data was transferred using ARPANET, and here we can see this is a breakdown of a basic data packet. And there we can see the source as well. So we'll go ahead and mark question 1 complete, read the above. Who designed or redesigned the creeper virus? That is, let me go ahead and grab his name. Ray Tomlinson. We'll go ahead and just copy that because I'm going to misspell his last name otherwise. How is data transferred through a network? That is going to be packet switching. And it's a little bit more complicated than that, but that gives you the general idea. Who created the first concept of a virus? And we're going to go copy his name as well. John von Neumann. And it's nice. The room creator, Java, has highlighted a lot of our answers for us. And we'll paste that, and that's question number 4. What did the creeper program print to the screen? We can grab that up here, and let's see. I'm the creeper, catch me if you can. We'll copy that. And delete that last bit. What does ARPANET stand for? That is going to be, if I can spot it, ARPANET, Advanced Research Projects Agency Network. We'll copy that down here. And then we have 2 more questions. Which team created the Network Control Program? That is going to be, give me just a moment, Network Working Group, I believe. And what is the first virus commonly known as? I think that's just going to be Creeper. There we go. Let's go ahead and dive into task 3, which is going to be Reaper. Reaper was created not too long after Creeper was released. The creator was Ray Tomlinson, which you may recognize as the same person to redesign Creeper. Reaper's purpose was to remove any copies of Creeper that it could find, but it moved differently to Creeper. And he's not 100% sure on the full details on this, but you can read about it from the reference down here. Ironic that the second virus really came about as a result of the first virus. Bob Thomas's main project was to develop a resource sharing capability known as RSExec, so that users could develop applications that could move to and run on another computer. Whilst installing RSExec, they also installed Creeper, and Creeper was then used to demonstrate the capability of resource sharing. This also worked through ARPANET and lots of other stuff. The information provided is vague, so if you want to research these viruses, so a lot of this, because it's very dated, there's not a ton of information on it, but we can research further if we want to. So using an RSExec API, and again linked here, the application could package itself and its data up and ship itself to another RSExec instance on another computer, which would then unpack and fire up the application. But in simpler words, Reaper would move its way similarly to Creeper and then get to work removing Creeper. A risk with any software is the possibility of bugs, and Ray said this was a simple program designed to keep track of which computers it moved to. As a result, it would be pretty trivial to visit them all unless the network became disconnected. According to malware.wiki, Reaper is called a nematode, which is a type of malware which removes other malware, but Reaper was actually the first antivirus software produced, and the term nematode is not commonly used, and again, that gives you an idea how it'd be a parasitic virus that would remove other viruses, and ironically being its own antivirus in that instance, so very cool. So who created Reaper? We'll go ahead and mark question 1 complete. Reaper was created again by Ray Tomlinson, and we'll copy that down here. And what type of malware may Reaper be known as? It should just be nematode. What was the first ever antivirus program known as? That's Reaper. If I can spell. There we go. What was Bob Thomas's main project to develop? We can go up here and let's see. A research sharing capability. And what was the term API stand for? Application Programming Interface. And that is something that you can Google pretty easily. All right, let's go ahead and move into task 4, which is going to be Wabbit. All right, the Wabbit, otherwise known as rabbit virus, was written in 1974. The name, which derived from Elmer Fudd's way of saying rabbit, which, fantastic. Again, as someone that grew up on Looney Tunes, this is, I love that this ties into malware. In the Looney Tunes cartoons, was one of the first self-replicating pieces of malware. The name also connotates to the fast pace in which the software would replicate itself, like that of a rabbit reproducing. Wabbit would work so fast that the system would figuratively choke on its resources and end up crashing. That's a problem. That actually can be harmful for the malware as well, because if the system crashes from it reproducing itself, the malware can't go anywhere else. Wabbit was one of the best versions of malware, not only for its ingenious idea, but also for its use in education. It was considered the first malicious program, and some might argue that Creeper was that due to Creeper's non-harming personality. Some might argue that Creeper might not be because it doesn't really harm anything, and it grew from the concepts of malware created from other computer scientists. The malware was only able to infect the machine it was put on and did not pass via network, hence why it is not classified as a worm. Now we would see a rabbit as being a form of a denial of service known as a fork bomb. I keep reading for further details. Variants of Rabbit worked on the system framework IBM OS and worked on similar to the original concept. Rabbit works by creating an infinite loop that continuously creates system processes and copies of the original file, creating a high number of CPU cycles. And the time that's the time of the execution of one process, which it chokes the system and consumes operating system resources, causing it to get slower until its eventual crash. And again, this is also known as a fork bomb. In modern days, a denial of service attack is an attack which makes a machine or network or server inaccessible to its users. You see this a lot of times with a denial of service attack done over the internet, where people will use various tools like low orbit, ion cannon, and other tools like that to actually start damaging servers and taking them offline so that actual customers can't use them. If you would like to see which computers use the IBM OS framework, read here. Very cool to dig into. IBM OS is very, very dated. The entire older computer ecosystem is also super fun to look at, especially if you start looking at things like mainframe hacking, where it becomes more relevant. And yes, those mainframes and those operating systems are still used today, so that's something to be aware of. All right, we'll go ahead and mark this first one complete, as we've gone ahead and read the information. What is a modern-day fork bomb also known as? That is going to be a denial of service attack. Rabbit was one of the first malicious programs, yes, and this is going to be from Elmer Fudd. It should be just Looney Tune cartoons, I would imagine. Again, very cool, especially as someone that grew up on those. Let's go ahead and jump into task 5, which is going to be Animal. In 1975, the first Trojan was written. Animal, created by John Walker, would act as a game and ask a user a number of questions to guess the type of animal they were thinking of. Whilst the user played the fun game, another program or subroutine called Pervade would create a copy of itself and animal in every directory the user has access to. A Trojan relates to a wooden horse that the Greeks built during the Trojan War. The story goes that men hid inside the horse, which was then given to the city of Troy as a gift. All of the men inside broke out and infiltrated the city from inside, winning the war. They did this at night after they brought the actual wooden horse into the city. Similar to the way that a Trojan pretends to be a friendly program, but secretly has a malicious purpose. Animal was not malicious, however. The program was carefully written to ensure that no directory structure or files were actually damaged. It was spread across UNIVACs, so Universal Automatic Computers, when users with overlapping permissions discovered the game. Eventually, the program was halted by an unintended operating system upgrade, which changed the format of the file status tables that Pervade used for safe copying. And that's file status tables allowed the program to avoid copying to the wrong area, causing damage. This meant that Animal could not find any safe areas to copy, and it actually stopped itself. This is similar. We'll see kill switch mechanisms like this in other forms of malware. Originally, Animal was coded in 1974 as a non-malicious 20-question game, but later the subroutine, a simple set of instructions embedded within a program, Pervade, was added in 1975. John thought it was a good idea. Animal would eventually be run by a privileged user, and it would copy itself into the system library, thus making it available to all users. John goes on to say that users exchange tapes with other installations, and as those tapes would most likely have Animal on it, John found the program spreading to other systems, and you can read more about that there. And again, this is kind of a novel idea where you have this game that is almost a forced version of shareware. Very, very cool. Let's go ahead and mark question 1 as complete, as we've gone ahead and read that. When was Pervade added to Animal? That's going to be 1975. Did John think this was a good idea? Yes, he did. What computers did the program spread across? Is going to be UNIVACs. What type of malware is Animal also known as? Let me go ahead. A Trojan. Who built the wooden horse? And that should be the Greeks. There we go. Just having a brain fart there for a moment. Let's go ahead and move on to task 6, which is Elk Cloner. Richard Skrenta, I just butchered his name, a 15-year-old high school student known for his pranks and practical jokes, created one of the first microcomputer viruses that spread outside of a computer system or laboratory, also known as in the wild, so actually went out to the general public. The malware works by attaching itself to the Apple II operating systems and spread via floppy disk. It was written in 1982, originally as a practical joke to mess with his friends. The technique that Elk Cloner used is a technique now called boot sector virus. The program was placed into a game's code until an unsuspecting victim started the game for the 50th time. This then activated the virus. Instead of launching the game, it would change to a blank screen that displayed a poem about the virus. Elk Cloner, the program with a personality. It will get on all your disks. It will infiltrate all your chips. Yes, it's Cloner. It will stick to you like glue. It will modify RAM too. Send in the cloner. If the computer booted from an infected floppy disk, a copy of the virus was placed in the computer's memory, and this then spread to uninfected disks that were inserted into the infected computers. Elk Cloner also wrote a signature byte into the disk directory, indicating that it had already been infected. And that's where we get to the idea of calling cards within malware, which is something that we still see to this day. Elk Cloner caused accidental harm as the Apple DOS disks had their reverse tracks overwritten, thus making it malware, albeit not intentionally in that case. Boot sector viruses are less common in modern technology, but are still relevant and important to know about. They usually infect the boot sector, the part which starts the computer, and once infected, they will try to infect every disk inserted into the infected computer, but can be removed. The computer does not have to successfully boot in order for the computer to become infected. And you see this with floppy disks. This idea was created when people would no longer give him their floppy disks in order for him to put private or other software on them. He then thought how he could alter people's disks without them letting him touch them, and then the idea was born. So the idea is that people wouldn't let him touch their floppy disks, and he wanted to mess with them still, so he just put something on the floppy disk that it would be passed around and other people would get infected. And, well, it's not as easy as that. Keep in mind that Richard was extremely talented and loved computers and is a professional. Elk Cloner took him 2 weeks to write an assembly language as well. Later, he found out that a friend in the U.S. Navy were among those computers that caught the virus, which is a big problem as this, with it spreading to the Navy, actually becomes a very, very big crime. And you can see there's a picture here of an Apple II operating system. A little dated. And then some references down here. We'll go ahead and mark question 1 completed. Question 2, which U.S. military regiment caught the virus? That's going to be the U.S. Navy. How many lines long is the Elk Cloner poem? Let's see. 7. Perfect. When was Elk Cloner written? That should be 1982, I think. Yeah, 1982. Is a boot sector virus more or less common in modern technology? That's going to be less. This is due to protections around the boot sector, especially with UEFI as compared to BIOS, which is secure boot mechanisms. How long did it take Richard to write the program? Let's see, 2 weeks. And which operating system was infected? Apple II, I think. And there we go. All right, let's move on to task 7, which is the Morris Internet Worm. You may have noticed that the creators of the viruses I have shown you previously are not exactly prosecuted or punished. The main reason for this is that the laws were different, and a lot of this was that this was new. Malware was new at this time. We didn't have laws for it because, and even as we're seeing at the time of this recording, a lot of laws around cybersecurity, because it's such a new issue, are very rough. And sometimes they can be draconian. A lot of times they can be very abstract because there's not a lot of understanding, especially in the majority forms of government, of how these actually end up working and how they become an issue. So, for example, when the Creeper virus was made, laws were not really as uptight about data protection and computer misuse back then as it is, as much as it is now. Malware is a really tough subject, and sometimes when you're doing something you think is right or fine, you accidentally cause unintended harm. As well as the computer scientists I'm going to talk about, this has happened in modern day malware. And again, a lot of this happens where people aren't necessarily trying to do something bad, but it can happen. Skipping a few years of malicious programs, we come across the Morris Internet Worm. Released in 1988, Robert Tappan Morris created a worm that was supposed to highlight security flaws of the academic networks that it traveled to. This worked, but not how he expected. The only downfall of the worm was that it failed to check which computers it had already been to, thus infecting many computers multiple times and causing a denial of service attack, commonly known again as a fork bomb. And this can vary a little bit. Fork bomb is a little bit more of a specific type of a denial of service attack. Fork bomb typically refers to this self-replication, so that's why we're seeing it used here. Morris was the first person to be arrested from a felony conviction in the U.S. under the 1986 Computer Fraud and Abuse Act. And if you are taking any IT classes, you will have to go over this law, especially within the United States, as this is a very, very important law as we started discussing computer security. The worm spread simply by exploiting known vulnerabilities in Unix sendmail, RSH, so that's remote shell, RExec, and weak passwords. Although this caused many issues, it did not make global awareness of the dangers of weak passwords. The worm infected some 2,000 computers within 15 hours, and it often took 2 days to get it off a single computer, rendering it pretty much useless. Reportedly, 6,000 computers were infected in the end, and 1,000 computers were able to and this was about 10% of the internet at the time, which is a big problem. 10% is a lot of computers. Berkeley R commands were a big way that allowed Morris to access the computers, and that is weak passwords. Similar to SSH, the worm was able to log in and execute commands on the system, just as you do on TryHackMe. Although this is a little different, as the way he did it was illegal in that specific case. Many commands that the Berkeley R command suite use look very similar as well, and this is because it was originally designed for Unix, which is what everything is a derivative of or a subset of in this specific case. And it was based on an early implementation of the TCP IP stack in this specific instance. And again, we have more references down below. Let's go ahead and mark question 1 as complete, and then what commands were a very big way that allowed Morris to access the computers? That is going to be Berkeley. Here, one sec. We'll type that correctly. Berkeley R commands. Who was the first person prosecuted for the Computer Misuse Act? We'll go and copy his name here. Robert Tappan Morris. What type of attack is known as a fork bomb? And again, this is a subset of that attack in this case. When was this worm released? 1988 for that one. How many computers did it infect in the first 15 hours? I believe that is 2,000. RSH is remote shell. And then which act was Morris arrested for? That is going to be the Computer Fraud and Abuse Act. Oh, and we want the... There we go. Maybe. Oh, is it the 1986 Computer Fraud and Abuse Act? Yes, it is. Let's move on to task 8, Cascade. To keep on the topic of the first types of malware, Cascade was notably the first type of malware to use a form of encryption. This encryption was not used to directly harm the user's data, but rather to keep the program undetected. As well as encryption, the virus was hard to detect because of its physical properties. The software was not obvious, but some mutations to the code caused bugs and made it a little bit easier to see. In the 80s, specifically on the Digital Equipment, a large computer company, Digital Equipment Operating Systems, a common file extension for executables was .com. Similarly to how a batch file, which this would be a .bat file, or .sh, a shell script file on the Linux file systems would work, this extension allowed text files containing commands to be executable. Something to note is the virus would not try to infect IBM computers by looking for the text containing the copyright statement. And this is one of those things that actually, as you get into reverse engineering and malware analysis, you can start looking for things like this in a similar way to that this is looking for copyright statements. You can look for strings like copyright statements within virus programs. Not necessarily copyright statements, but you can find consistent strings that you can start finding this identification, and just little bits that are consistent that you can latch onto. This failed, however, and a bug allowed it to infect all computers. Later on, at headquarters in Belgium, owned by IBM, so the IBM headquarters in Belgium, was accidentally infected, and this led to them releasing their private antivirus software. Another thing to note is that the virus would only work by executing the infected file. Each time the infected file was run, it would slowly make changes to the computer. How would you know if your computer was infected? There were a few different ways to tell if your computer had been infected with the Cascade virus, but this differed with the variants of Cascade that were released. In different areas, different forms of the virus were found. Some were believed to have mutated code, and some did not use encryption, and one infected 2 companies but did not use its trademark sign, making it harder to detect. And keep reading for more information on that. This, we can see that there's different ways that malware can perform, making it a little bit harder to detect because it's not always consistent. All the base source code for these different variants were the same, including the last one that was found. The creator of the virus was presumed to have used another assembler, but with the same code, hence the change. And that's where we can see assemblers, different compilers will come up with different ways of actually constructing the code that the machine is going to run. The first obvious tell was checking your file sizes. Infected files would have a much larger file size, specifically by 17,000 or 1,704 bytes in most file variants, and simply checking this would allow you to properly remove it from the file system, as it has to have all the virus code in there too. In one of these variants, a single byte had seemed to mutate, causing a bug in the code, making Cascade infect one file multiple times. The second way of telling was checking the host file. Cascade changed the first 3 bytes of the host file and added it to the first 3 bytes of the virus's main file. I'm unsure why it did this, as different sources either do not cover it or do not give a full explanation, but if you're interested, go ahead and research this. This is like the obfuscation technique to make it not be as apparent on the actual system, as it changes the way that it actually appears and you have a different signature in that specific way. Then, by October 1st and December 31st, the payload would activate. This DOS malware would make the text fall from the screen one by one until a heap of characters were at the bottom. Some would say this was an accident. If another payload was running, like that of Techno, and Cascade would wait until Techno had finished until it made the text fall from the screen. On top of that, the computer would emit noises, which was very popular in different viruses at the time. And this is because, obviously, that's very annoying. Cascade was truly a big virus, and some accounts claiming there were 40 different variants. If you find it interesting, then you should definitely research it, but this room is mainly an overview of viruses and how they work. So again, you could do a little bit more research onto that to see the full extent of that. Let's go ahead and click complete on number 1 there. What was the name of this virus for number 2? That is going to be Cascade. What file extensions would this virus infect? That's going to be .com files. How many variants of the virus were possibly found? That's going to be 40. What operating system would the virus run on? Let's see, I believe that's DOS. Which operating system or framework would Cascade try to avoid? That's going to be IBM. And how many bytes would be added to your file if it got infected? 1,704. Let's move into the last task, which is going to be thank you for reading. You made it. Thank you for joining the room, and I hope you enjoyed it. Most of the information that I use can be found, or in this room can be found elsewhere, and contact Jabba if you have any questions. Definitely worthwhile to go through and research these 2 other variants as well. I Love You, or the Love Letter Worm, is very, very cool. I definitely recommend reading about this, especially if you go through and read about the impacts that it ended up having. Same thing with WannaCry, and there is a Darknet diary, or I think there might be a couple actually on WannaCry. Definitely worthwhile to read into, as there's a lot that happened with surrounding that virus, both on the offensive end and on the defensive end. Otherwise, we'll go ahead and mark that as completed, and that's going to do it for the History of Malware room. If you have any questions, feel free to ask me in the comment section below or in the DarkSec Discord. I have, as always, both the TryHackMe official Discord and the DarkSec Discord linked in the video description below. If you enjoy this content and want more of it, subscribe to me on YouTube and follow me on Twitter, and I will see you guys next time.